Hi, my name is Logan Hubler, and this is the interactive advanced concept presentation number 4, the elephant toothpaste. So for this experiment, the materials I used were 3% hydrogen peroxide. I could only find 3% at the store, not 10% like the video showed. I used dish soap, some green food coloring, and dry yeast. And this is what my experiment turned out like. It did explode a lot. I just had to clean it up a little bit so I could actually pick it up. So first, I added the hydrogen peroxide, to a cup, and then I added a few drops of dish soap to the hydrogen peroxide in the cup. I then added a few drops of this green food coloring to the cup with the hydrogen peroxide and the dish soap. And I gently swirled up the mixture just in the cup. And then in this cup, I added the dry yeast, this entire packet of the dry yeast, and hot water. And I stirred with this spoon. And then I poured the active dry yeast and the hot water mixture into this cup with the hydrogen peroxide, the dish soap, and the green food coloring. And the reaction occurred. All of the reaction flew up outside of the cup. That's why I'm outside, because I knew it would explode and I didn't want to ruin anything inside, so I did it on my grass because it got all over the grass. As we saw in the video, the reaction proceeded through and went out through the cup. So to answer the question, why the elephant toothpaste occurs. The elephant toothpaste occurs because elephant toothpaste is a foamy substance caused by the rapid decomposition of hydrogen peroxide using yeast and hot water as a catalyst. How rapidly the reaction occurs depends on the concentration of hydrogen peroxide. As I said, I can only find the 3% hydrogen peroxide at the store, and at home I only had the 3% hydrogen peroxide, not 10%, which is why when you use 10%, it occurs differently and quicker. The catalyst in this experiment was the yeast and hot water. The yeast and hot water breaks the hydrogen peroxide into oxygen gas and water. The oxygen gas produced gets trapped in the soap, which then produces a big ball of foam. As we saw in the video, the big ball of foam was produced. This also produced a big ball of foam. It doesn't look like it now, but as I said, I had to clean it up so I could pick it up for the video and to show it. The dish soap adds additional surface tension, which allows the bubbles to get trapped and creates a lot of foam. As I said, it was foaming everywhere. It was all over the grass. It was actually pretty cool to see, because I didn't think it would actually work, but it worked and it was pretty cool. The reaction continues as long as there is some hydrogen peroxide and yeast left. Now, once either the yeast or the hydrogen peroxide runs out, the reaction stops making new foam. So in order for the foam to keep spewing through and squirting out the top of the cup, you need either hydrogen peroxide or yeast. And as I said, if one of them runs out, that means your reaction will stop occurring because it needs one of them to keep going. So just to sum things up, restate the broad ideas that I concluded from this experiment. The yeast contains an enzyme called catalase. Catalase breaks down hydrogen peroxide into oxygen gas and water. As I previously stated, the hydrogen gas was broken down into the oxygen gas and water. The oxygen gas gets trapped by the dish soap and a large foamy solution results. The foam runs out of the top of the bottle or cup. In this case, it was a cup that I used. In a chemical reaction, a catalyst is used to speed up a reaction. In this experiment, as I previously stated, the yeast and the hot water mixture that was previously in this cup was the catalyst for this experiment. It helped to speed up the reaction. The yeast and hot water quickly broke apart the oxygen from the hydrogen peroxide, which is why it was used as the catalyst in this experiment. So as I said, my experiment did work. I saw the foamy bubbles spew out of the top like I did in the video. It was all over my grass. I just had to clean up the cup, as I said, so I could hold it up and actually touch it because it was all over the cup. But yeah, so that's the experiment, and that's why the elephant toothpaste occurs. Thank you.